Hello everyone. So today we'll talk about how to record or how to log a TensorFlow model under MLFlow. So we'll see experiment tracking for TensorFlow model using MLFlow. So in my screen, if you see like I have recorded multiple experiments, and if I select one of the experiment, then here you see like under this mnist experiment, we have 2 runs recorded. And if you go inside one particular runs, then you can see what are the logged parameters and what are the logged metrics. Okay. And then if you go a little down here, then you see all the artifacts which contains the model and Conda version, Python version, all those things. Okay. And then later, once we logged, then we'll also see like how to load this logged model and do the prediction. Okay, on live data. So we'll see all those things. So basically, to do the experiment tracking with respect to TensorFlow model, there are 2 methods. So TensorFlow exposes like MLFlow exposes for TensorFlow the Autolog method. So if we use Autolog, then it logs the metrics. I mean, all the metrics by default. We'll see that like what all metrics it records. So if I just quickly show you, like if you go to the default, so here this particular one I have recorded using Autolog method. So here you see like batch size, class weights, epochs, all nitty-gritty details it has recorded, and then metrics. These are the different metrics, and then remaining is same. Okay, so we'll see both the methods like Autolog and the default method for logging the experiment. So let's start. Okay, so I will start from the very basic. Okay, so if you want to do the practice along with me, then please open the terminal and everything, whatever I'm going to open together, and then you can pause the video and then you can just execute the statements along with me. Okay, so let me close it, and I'll close this as well. And now if I go here and I open my Anaconda prompt, then I will first of all I will activate the environment. So I have created the environment called TensorFlow. So I have already created a video on how to create a Conda environment. Then you can refer that one if you're new on how to create the any Conda environment. And now let me go to the project folder where I have kept everything. Okay, and from here I will open the Jupyter notebook. So it will open the Jupyter notebook for me, and here I have placed all the code which I'm going to explain you. Okay, and let me open one more Anaconda prompt and activate, because from here I'm going to open MLflow UI. Okay, so make sure you open the MLflow UI from your current working directory where you are working. Okay, so that all the ML runs and models are recorded there. Basically, I'm going to use my local file system as a database for logging the experiments or artifacts. Okay, but you can also use any other actual database, for example any MySQL database, SQLite, or any other. Okay, so in my previous video I have already given the reference like what all database you can use. Okay, but today let's focus mostly on experiment tracking with respect to TensorFlow. So what I can do, if I do MLflow UI, then it will simply open me the UI for MLflow. So just a minute. Yeah, so now if you open this URL, let me copy this and paste it here. Okay, so now you see here. So forget about all these things. Okay, I will explain. So in your case, it might be the case like you don't have any experiment recorded because you're opening the first time. Okay, so no worries. Let's start. So here and here also you forget about all these files. Okay, so for you like you just open a new blank folder, and there you go here and open a file with your environment. Okay, kernel environment. So that you can select. So if, for example, if you are selecting TensorFlow, then I mean, whatever the environment in your case, so it will open a blank file here. Okay, so that you can do, and here you can you start executing the statement one by one, what I'm going to explain you. So this is the file I have created for experiment purpose for TensorFlow model. So let me clear all the output so that we can freshly execute everything and see live. Okay. So here, the first thing how I'm proceeding basically. So I'm going to quickly cover basic model building using TensorFlow for image identification. Okay, and then later I will spend more time on explaining like how to record a TensorFlow experiment using MLFlow, and then load the TensorFlow model and do the prediction. Okay, that is more important. So that's where I'm not spend much time on explaining the how to create TensorFlow model, because I'm assuming you all already know that thing. Okay, so let me quickly import certain libraries like TensorFlow STF and MLFlow. So let me import them. So these I have already installed inside my Conda environment. So let me quickly show you like what is the Python version and MLflow version and TF version I'm using. Okay, so if I run this, then you can see like my Python interpreter is coming from this environment, so that's good. And then this is the Python version 3.10.11. Okay, and then TF version is 2.10, and MLflow version is 2.3.2. Okay, so make sure like you also have these versions only to execute further thing. I mean, for with other version also it might work, but sometime I will show like, for example, TensorFlow.autolog method that has some dependency on a particular version of TF. Okay, so that I will explain. Okay, so these are so if you are getting some version conflict, then you can come back here and see well what versions I'm using. Okay, so now let me quickly load the data basically here. So TensorFlow.keras.datasets provides mnist dataset, fashion mnist. So it has a different clothes dataset, okay, like t-shirt, top, dresses, and everything, and some sandals like footwears as well. Okay, so let me load here. So using this statement, I'm loading the data, and then I'm just creating a train test labels and data separately, and these are the class names basically. And then using this method, I will return train images and train labels and test images, test labels. So let me quickly execute it. And from here, I'm calling this method. Okay. And now I have returned with these data sets. So let me print those things. I mean, they're safe. Okay, so train images are around 60,000 with the shape of this, and then we have in the test images we have 10,000 images. Okay, so what I'm going to do basically, I'm going to further divide the test images into the validation and test, so that we can will like while training while building the model, we'll see okay, train and validation lost, and then separately we'll do the model evaluation on test data. Okay, so that's the normal machine, I mean, like model building part. Okay, so let me execute this part also, and here I got the validation set as well. So validation set also contains 5,000 images, and test set also contains 5,000 images. Okay, and the label also like it should be the same. Otherwise, you might get some problem. Okay, so now further let's do some basic pre-processing. So here, guys, I'm simply what I'm doing basically, I will be scaling the images. Okay, so you can do a lot of pre-processing for the images. So that I'm not going to show, because I said already here I'm mainly focusing on the experiment tracking. So that's where like here I have created the method under that you can do a lot of things, right? So the first thing, like check image pixel, like what image size it is. So let me do that. And then here you see like we have 0 to 255. So here it is 250, and then top at 255. Okay. So image size, like pixel size is like 0 to 255. And then we need to scale it to 0 to 1. So that's what I'm created this method. And let me run this scale method for all the train images, validation images, and test images. Okay. So I did that one, and then verify data format. So what this I will do basically, after scanning all the data formatting is same, we can reproduce the images or not. Okay. So let me do that one. So here I have simple plotting like image plotting code. Now let me call this code for to verify the train data, validation data, and test data. So here you see like train data. So even after scaling, so these images are properly I mean, there is no problem basically after scaling. Okay, they are properly printed. So here you see like this is a ankle boot image, t-shirt, some t-shirt top, dress, again, okay, sandals. So these are the different images, and same is valid for your validation data. So it should also look like similar. Okay, a sequence might vary because these are randomly sampled, but yeah, they should be same. And same case happen for test data as well. Okay, test images. So now we have our train test validation images ready. So let's start with the model building. So here again, I'm not doing a lot of fine tuning. I will build a very basic model. Okay, so like I've created the method TF model build, and inside that we have a sequential model. So like we have flatten layer and two dense layer. That's it. Okay, and here I'm using the activation as a ReLU. So now a model build, and then we can simply compile. In compile, we can give the what is the optimizer, what is the loss function we are using, what is accuracy, like what is the metrics. For example, here you can use precision or any other metrics. Okay, so I'm using basic accuracy, and then finally, once it is done, so we can train the model. And now, guys, here. While training, if you are defining MLFlow.tensorflow.autolog, okay, if you define this, then you no need to explicitly write any experiment tracking code. It will start as model start getting trained. It will MLflow will start logging those model parameters. For example, training accuracy, training loss, validation accuracy, validation log, what is your batch size, what are your epoch number, and all other metadata part. Okay, it will record everything by default. Okay, so that's where before you start training, you have to define this part. Okay, so and then if you want to understand what every entire what this variable is doing, basically, so it will record after every second epoch. So what you can do here, you can go and you can read every variable, like what are the different variables. Okay, so by default these are true, and you can also define the like registered model name. Okay, I'm not defining, so by default it will record a experiment under the like default variable, default experiments. Okay, so that's fine. You can define all those variables, and you can see like auto logging is known to be compatible with the following package version. So here this is very important, guys. So to use auto logging, you need to have your TensorFlow version between these range. Otherwise, you might face problem. Okay, so that's where at the top I have shown like what TensorFlow version I'm using basically. Okay. So this is fine, and then I have a train model code. So this is nothing but simple model.fit. Here you need train images and train label, and then what is your epoch size, what is the batch size, and then validation data. Okay, with this basic parameters, I'm going to train my model. So let me define it, and then here I'm calling this. So tf underscore model underscore build, that this is the first function. Here it will call this. So this model build, then model compile, and then finally model training. Okay, with epoch and batch size defined. So let me run these things. So this will run one by one, and now you see a model training has been started. Okay, so now because I have defined autolog parameter here, autolog this. Okay, so it will start logging all these parameters in my MLflow UI, and make sure before you start auto logging, your MLflow UI should be running. Okay, so that's where this I have ran in the very first. And now if I just refresh it, so under default, if I go, so it has not logged yet. Yes, somehow it is not shown. It has to come here, but you know what is happening here. If you go here, we have not executed this. I was explaining, but I have not executed this part of code. Okay, so let me do it again. No problem. Okay, so let me execute it. And now I will do it again, train the model, and I will call this function again. Okay, so now it will again retrain the model, no problem. Okay, and now as it has started training, now if you go to your MLflow, so you must see it is auto logging. So one new run might have created. Yeah, now you see 9 seconds ago. So just now it has created this run under a default, and if you go inside, so it will start logging all those parameters, like what is batch size, epoch, and all those things. It has recorded. Okay, with the help of auto logging functionality, and it is recording what is your accuracy, like training accuracy, training loss, and validation accuracy and validation loss by default. Okay, and you see here a model has still not come because it is still running, and the moment this has finished all the epochs, it is still in 5th epoch, and the moment it finished all the 10 epochs, you will see your model is logged there. Okay, so till now it has only finished record. I mean, it is still recording the parameters. So let's refresh it here. Yeah, it's still not. It will come the moment it finishes. Okay, so it is in the 8th epoch. So let's wait. Yeah, so now it is almost finished. Okay, so it is still in progress, doing some background work. Okay, so it is saying it is written to, and it is about to finish, and now we'll go there. Okay, so now if I refresh, see all the model has come here. like all the metadata. So here, if you just expand the data and go inside models, and here you see your saved model is there. Okay, and if you click here, then you can do the registration part as well. Okay, so now you see here, see, in normal scikit-learn framework, if you record the model, then in my previous video I have shown you, okay, then you don't record the model schema. That is the model signature, means what is your input data type or size, and what is your output schema. Okay, so this part is something new in your TensorFlow based models, and here you see lot of metadata information is there. So this is not exactly similar in scikit-learn framework based models. Okay, so now let's go back here. This is recorded. Now let's see, like if we want to record or do experiment tracking manually, we have to decide, okay, what parameter we want to log and what parameter we want to not log, basically. Okay, so we'll do it by ourselves, not with Autolog fence. Okay, so for that, let's evaluate all the, what is your training loss, what is training accuracy, all these parameters explicitly. So what I'm getting here, so using model dot, so model is already trained. So with this function, what we have defined here. Okay, so we have model available with me. So if you just do model dot evaluate, so what is it is telling? Test accuracy is not defined. Where is test? Okay, so it is not test accuracy, it is training accuracy. Okay, so let me run this. So it will run in a moment, and same thing I need to do here. Yeah, okay, so now you see here, we have training accuracy is 91%. Okay, so now we have, and you can also print the train loss. Okay, and similarly we can evaluate by sending validation images to the model dot evaluate and validation labels. Okay, then you will see what is your validation accuracy. So that also we can print, and similarly we can do for test accuracy. Okay, and now if you want to predict basically what exactly it is doing. Okay, so what we can do, model dot predict, the same predict method. Okay, so like we do in scikit-learn method, we can pass the test images, and here you see for the 0th image it is printing it is predicting like this. So what it does basically, so see, it is little tricky to understand what are these numbers, because these are ND array. Okay, so what we can do, we can get the maximum number. So see, this is negative, this is negative, this is positive, this is positive. Okay, what is the max? So to instead of doing this manually, what we can do, we can take help of NumPy, and we can do an np.argmax and prediction 0. So let me execute this. So now it is returning second. Okay, so 0, 1, and 2. This is the highest number. Okay, and this is the prediction. And what 2 means, let's see, like what is the, so model is predicting second, means second image. Okay, for this, and let's say what is the test label, it is also 2, and what is the class with respect to the t-shirt. Okay, so it is predicting t-shirt, and it is correct because these two are matching. Okay, so that's what we can do. And now, and what is next thing basically, guys? As I told, till now we have done experiment tracking using Autolog method of MLFlow.TensorFlow. So that is very good basically. But still, if we want to have the freedom with us, and we want to decide, okay, what we want to log and what we don't want to log. Okay, so for that we can create a TF experiment tracking method, and for that we can pass the experiment name, run name, what is the batch size, what is epoch, because these all things we want to record, and what is the train loss, training accuracy. This all we have calculated basically, test loss, test accuracy, and what is model signature. Yes, so if we want to do it manually, then we have to calculate model signature as well. So if you go to MLFlow, here you see this is the model schema, right? Model signature. What is your input schema? What is your output schema? So that you need to calculate manually. Okay, so if you want to do all these things manually. Okay, so this is the experiment. So I will show you like how we can record model signature. So MLFlow.set experiment, whatever experiment name is coming, here you can set. There it has logged on the default experiment. Here under default experiment, it has created this run, but now we want to decide which experiment we want to create. Okay, so we will pass the experiment name, we will pass the run name, and then MLFlow.log parameter, we can log the batch size, log parameter, we can log the epoch, train loss, training loss, validation loss, validation accuracy, test loss, test accuracy. Okay, and then finally we can do MLFlow.TensorFlow.log model. We can log the model, and what model name? We are giving model name as mnist, and we have model parameter. Okay, and then signature we can pass. So this is the method, and ultimately you need to end the run. Otherwise, second time if you are running, then it might give problem. So now how you can get the signature? So using MLflow.models.signature, you can import infer signature, and then infer signature you can pass the test images, and model.predict scale test images. Okay, if you pass this, then it will give you the image schema, what is input and output schema. Okay. So this is taking as an input schema, and from this it will output schema basically. So you can see if you are confused in any steps, what you can do, you can just do shift tag. Okay, so let me run this first, otherwise shift tag will not work. Okay, so if you just hover and do shift tab, okay, then it will tell you, okay, what is the parameter it is expecting. So model input, okay, model output. So that's where two inputs. And what are these? Basically, you go down, then you will have the definition for that as. So parameter model input, valid input to the model, a subset of the training data set. So that's where I have passed the test data set. Okay, so you can pass the scale test, scale train images as well. You can pass scale well images as well, because all these three schema should be similar. If you have done any mistake in the above, then of course you might face some problem, but all these three schemas should be similar. And then our model output, valid model output, model predictions for the subset of train data set. Okay, what model is producing, basically what is the output schema. Okay, because same schema you will be expecting while you predict. So that's where you can do. So here you can, I have passed test images, so but you can pass the training images, because at least should be similar to training images. Okay, you can pass the training images as well. And then we have defined this experiment tracking method. We have got the model signature as well. Now what we can do, we can define the experiment name. So this is the experiment name, mnist experiment plus experiment timestamp. So timestamp I have created because suppose that today I'm running and tomorrow I'm running the same code, then I should get new experiment with the date time appended. So it's just a naming. Okay, so that if you come here, then it should create like this mnist experiment and some date appended, so that we can distinguish which is our experiment. So now if I just append live here, okay, as well, so that you can differentiate what we have created just now. Okay, if you go here, there is no live experiment here. Okay, so now let me create this. So we have defined the variables, and let me quickly execute. And now I'm just going to call this experiment, because I'm doing manually. Okay, I will just call this experiment from here. So now all variables set. Okay, so let it run. So it will quickly log our model. Now let it finish, give it some more seconds, and yeah, it finished. And now if you go here, just refresh it, then you see here this new experiment got created. And if you go inside here, then new run has been created with live mnist experiment, and this is the name we have given, right? And if you go inside, so we have logged only two parameters, that is batch site and epoch, and then we have logged 6 metrics like test accuracy, train accuracy, validation accuracy, and corresponding loss as well. Okay, and here is our model, and here this is our model schema. Okay, so now if you compare with Autolog, here we have not logged everything. That's where here we see only specific detail what is needed for model prediction. But if with Autolog, it log many more things. Okay, and now see here, this is the run ID. Okay, so now our experiment is recorded. And now if you want to load the model from MLflow and do the predictions, what you can do, you can simply copy this whole thing. Okay, and come here, and you can MLflow is already imported, and just change this. Okay, with the newly recorded experiment. And then how you can load the model, it is already defined here. It is already defined here. So same thing. Okay, you can load this model and you can predict like this. Okay, so let me show you. So here I have used mlflow.python.load model, and logged model path you can give. Okay, and then what you can do, loaded model.predict scale test images. Okay, you can do. So in my previous experiment, like what I was doing, so I was just getting some type error. Okay, it was, so a test image somehow got in integer. Okay, dot 01. So that's what I need to convert, and you needed to convert that to float. Okay, so if you get that error, then you can just convert to that float, but this is not needed. Let's see. Okay, and now let me run this. So it will run quickly. Okay, just give some more seconds to it. Yeah, now it is doing. Yeah, done. Okay, so now this is the prediction again. So these are the some numbers. Okay, So don't worry about that. We can simply do argmax. I have already explained. Okay. So for prediction 0, this is anyway prediction 0 is printed. So no need to print again, and we can do argmax. So here just do 0. Okay. So you can print it again. No issue. So now you see here, it is predicting 2012, second, I mean third index. Okay. And then for this also, test label should also be 2. It should be equal. And then if you just print the class names, okay, class names and 0, what is there? Okay, t-shirt. Okay. And now similarly, if what you can do also, you can just print some maybe fourth. Okay, fourth image you can predict for, you can see the prediction for fourth index. Okay, and validate if it is exactly equal to the test level or not. Okay, so let me run this, and so for fourth it is predicting 4. Okay, and it is 6. So this is a mismatch. Okay, so here model is not doing good, right? So it is a quote, but it is predicting something else. Okay, so whatever in the this fourth index. Okay, so like it is 6 basically, but here it is predicting 4. Okay, let's see for some more numbers. So that's why it is not 100% accurate, right? Some mismatches will be there. Yeah, this is correct. It is predicting exactly sandal, right? So these number and these numbers should be same. Okay, so now this is how you seen. So now this is like a normal ND array, so like in normal continuous values. But if you want to convert these to probability value, then of course you can do like this. So same way, and you can have a prediction in terms of probabilities. So now like you see these numbers, and you can see like it is 4.96 into 10 to the power minus 04. It means like you just prepend 3 zeros, so 0.004. It is much lesser. So it is like around 99%, right? 0.99. So 99%. So that's a 0, 1, and 2. It is predicting second. So this will be the highest, and remaining are low. So that's where if I just do here 0, it will give me 2, right? So 2 we got. Okay, so I hope this is clear now. So I will share this notebook to you all. Okay, so just execute and let me know if you have any problem at any stage. And I hope like you now know how to record tensor. See, TensorFlow model experiment tracking slightly different from normal scikit-learn experiment tracking. Okay, so that's where I created a separate video explaining TensorFlow experiment tracking. I hope you enjoyed the video, and let me know if you have any doubt with the comment section. And that's all for today. And if you're liking, so please don't forget to subscribe my channel and share with the ML communities. So thank you.